Hello everyone, this is Rajat from IIT Bombay and today we'll discuss question 7 of 2019. The question based on the concept of mycelial formation. The question is on the topic of how this mycelial formation is accompanied. First option is decrease in overall entropy due to ordering, increase in overall entropy mostly due to increase in solvent entropy, increase in overall entropy mostly due to increase in solute entropy, and increase in overall entropy and decrease in enthalpy. Now, generally, it is a thing, is that something like that. So, the two things that we need to know regarding mycelial information, the how the entropy changes, because that will give us the answer uh, and help us, and the enthalpy changes. Now, we'll focus on how this mycelium is formed and what are the things that will happen when we discuss about entropy and enthalpy. Now, in general, when surfactant molecules or ions cluster together, they forms this kind of mycelial formation, where these are the, let's say, hydrophobic tails that are there, and they congregate in the middle section, concentrated in the core group of the mycelium, whereas these hydrophilic groups that are there, they tend to protect those hydrophobic, let's say, um, tails from the medium. We generally take the medium is generally, let's say, a polar molecule or something like that. Something like that is there in the surrounding sections. So this hydrophilic heads protect or provides protection to those hydrophobic chains that are there in the inside the mycelium itself. Now this when this mycelium forms, so depending on that depends on the types of surfactant in general. There are there are specific concentration for that surfactants known as the critical mycelium concentration. In the short form, people write as CMC. So this CMC depends on surfactant itself, and we not go into what is the critical mycelium concentration and how this changes the surfactant. But we have to focus on when this critical mycelium are forming, what about the changes are there in the entropy and the enthalpy itself. Now, let's focus on the enthalpy first. In case of enthalpy, whatever it happens is that it depends on two kind of interaction. First, as this hydrophilic hydrophobic chains are coming very close, so interactions that are there between the hydrophobic chains is one of the parameters. It will decide what kind of interactions are there and what kind of restrictions are there. Depending on that, the enthalpy will change. If there are let's say only non without a non-covalent interaction, in that case enthalpy may change pretty slowly and it will become negative and so on. But if let's say there are some polar charges or something like that, then enthalpy gets positive, something like that. So in this situation, similarly, the next interaction that is there and that is more important is the interaction between the hydrophilic heads that are there, that are protecting the hydrophobic chains, and the medium that is there. It can be polar, it can be non-polar, it can be different. But in case if let's we think that it's nicely generally formed when it is a polar medium. So polar medium, the interaction between them, if the interaction is good, interaction is favorable, then this become negative, and if not, then it becomes less negative or positive, something like that. So the general scenario is that without knowing exactly what is the situation is that, or whatever the exact condition has been provided, we can't comment exact answer from these two conditions. So the thing is that enthalpy can be negative or positive. That means it can be exothermic or endothermic depending on whichever the condition or whichever the interaction is more prior. So the catch line from all the things is we can't comment on the enthalpy without knowing the exact conditions that was there or without any measurement. So enthalpy can be negative, enthalpy can be positive. So whatever the options that are there in the, let's say, the last option that was there is not a correct answer because we don't comment on that there will be a decrease in enthalpy, something like that. Now let's come back to the entropy part that was there. The next section that was there is entropy. Now entropy, it can be seen in two sections. One from the solute or surfactant, whatever the thing is, and the next is the solvent. From the solute part, there no confusion in that case. Molecules are getting ordered. They are forming an ordered conformation, and whenever an ordered conformation generates, it is interacts the del S or entropy for the system will be negative. And now that is the case. From the solute perspective, it is negative. Now let's come to the solvent perspective because whenever we see that micelle is forming, it's a effect that is there in the solution itself. So we have to consider solute and solvent itself. Only considering the solute interaction or solute uh, entropy change will not answer or the whole scenario. For the solvent, what will happen is that the as there are small surfactant molecules, let's say something like this, there's when there's small surfactant molecules are there, the water molecules or the solvent molecules have to make small cages, and more number of water molecules need to be utilized for this kind of case. But let's say instead of small cages, if this hydrophobic or the soil surfactant molecules make something like a box or interaction together, when they form micelle, what happens is that these water molecules now have to provide or form a bigger cage with small number of water molecules comparatively compared to the number of water molecules to be used in a small number of more small cages. So as a result, more number of free solvent molecules is there. So the thing is that free solvent molecules will increase when a micelle is formed, and that is to del testing is positive. It was seen that after the net information, the net uh, entropy change of the system becomes positive due to the overall interaction between considering these two scenarios that are there. Now let's get back to the question that was there. So it was first of all the decrease in overall entropy in the ordering is it's okay. It's for the ordering for the micelle surfactant molecules, but it is not a complete answer. There is a decrease due to overall entropy, but there will be no decrease in the overall entropy. That is the case. There will be decrease in the solute entropy due to ordering. So this option is the wrong one. This is not the right one that I will consider. Then the increase in overall entropy mostly due to increase in solvent entropy. It might be a option. It might be an option. We don't know exactly. Let's check the other one. Increase in overall entropy mostly due to increase in solute entropy. Increase in solute entropy is a wrong scenario. As you see, there will be a decrease in solute entropy. There will be no increase in the solute. And now the increase in overall entropy, that was right. But decrease in enthalpy, we can't exactly be sure about decreasing the enthalpy. It can be increasing enthalpy, it can be decreasing enthalpy. So option D, we are not sure. It's not a correct answer. Option C is completely wrong. So the only option that is there remaining is option B, and the answer that is there in the answer sheet is also answer B. So that's how you carry this question and answer get an exact answer that you want to know. If you want to know more about this, let's say surface and interfaces and how this micelle is formed and know great details of this micelle formation, you can check this link. The lecture series on Introduction to Polymers by Professor Dibakar Dhara, Department of Chemistry, IIT Kanpur. That's all from my side.